Good day, everyone. We are the Group 3, and our topic is all about mass spectrometry. In this report, you will learn what are the principles, the importance, and the environmental application of mass spectrometry. First, I will define what is spectrometry. Spectrometry is a tool used to measure and analyze the properties of lights and electromagnetic radiation. It is commonly used in various disciplines, such as in chemistry and physics, where determine the composition, structure, and properties of a substance. So, mass spectrometry is a tool useful for measuring the mass to charge of one or more molecules present in a sample. The measurement often used to calculate the exact molecular weight of the sample components. So that's all about the mass spectrometry and its definition. On the next presenter, it tackles all about the mass spectrometry principles and the process.
Mass spectrometry principles. Mass spectrometry is a powerful analytical technique used to identify and quantify chemical compounds based on their mass to change. Let's have a briefly explanation of its principles. Number one, the ionizations. The process where our simple atom or molecule are being ionized, meaning the sample of atoms or a molecule are converted into changed ions. Number two, the mass analyzer. The ions are the accelerated and pass through a mass analyzer. In a part of these ions subjected to MZ values, they are being sorted always. Take notes that there are different type of mass analyzers, such as quadrupole, time of flight, magnetic sector, and ion trap, and where each has its unique principle of operation.
Detection: the process where detectors measure the abundance of each M over Z value. As the ion passes through the mass analyzer, the intensity of the ions are measured and ion signals in the mass spectrum, where it provides information about the different ions in the sample. Data analysis: and this data processed and analyzed to identify compounds and their abundance. In this part, the resulting data is used to identify the compounds where it involves comparing the obtained mass spectrum in the sample based on the characteristic mass pattern. Always remember that different mass different mass spectrometers may employ variation, but the fundamental principle of measuring ion mass to charge ratios remains consistent. And by that, allows versatility to a wide range of analytical tasks in different fields.
This image illustrates mass spectrometry, a technique measuring ions mass to charge ratio to identify and quantify molecules. It begins with ionizing the sample using 70 electron volt, balancing ionization and fragmentation. Cations are accelerated, passed through a mass analyzer, and detected to create a mass spectrum. This spectrum aids in molecule identification and quantification. The process occurs in a gaseous state under low pressure to prevent ion gas collisions. Mass spectrometry is widely applied in chemistry, biology, and environmental science for compound analysis, routine research, and pollutant detection.
Environmental application of mass spectrometry. When you say mass spectrometry is a versatile analytical tool with diverse application in environmental science. It helps researchers and policymakers assess and mitigate environmental pollution and study ecosystem dynamics. So, mass spectrometry continues develop and integrates for greater insights into environmental challenges. Mass spectrometry has both qualitative and quantitative uses. So, here are the several applications of mass spectrometry to the environment. So, first is air quality monitoring. So, where the MS used to analyze air pollutants, participate matter, gases like ozone and nitrogen oxides. The MS help to understand the composition of the atmosphere and the quality of air in urban and industrial areas. So, air quality monitoring refers to the process of measuring and assessing so, the quality of the air in a specific location or region, it involves heat collection or data related to various air pollutants and environmental conditions. So, this data is typically used to evaluate and manage air quality, identify pollution sources, and assess the potential health and environmental impacts. So, second is water quality analysis. MS employed to detect and quantify contaminants in water sources. It aids in ensuring the safety of drinking water and assessing impact of pollution on aquatic ecosystem. So, water quality analysis is the process of evaluating the chemical, physical, and biological characteristics of water to determine its suitability for various purposes, such as drinking, industrial use, agriculture, and maintaining aquatic ecosystems.
Soil analysis is used to analyze soil sample for organic contaminant, heavy metals, and nutrients. Next is environmental forensic. It is used to employ to identify the source and origin of environmental contaminant, such as oil spill or illegal dumping of hazardous waste. It is also the scientific study of contaminant in the environment with the specific view to identify the source.
One, monitoring greenhouses. MS measure greenhouse gases such as CO2 and CH4. So as we all know, CO2 is the carbon dioxide gas naturally produced by animals during the respiration and through decay and biomass. So CH4 is methane is colorless, odorless, or flammable of gas Japanese sila neutron oxide of N2O. These measurements are crucial for climate change research and policies. Next is environmental metabolomics. MS is employed environmental metabolomics to study the metabolic response of organisms to environmental stressors. So, ang mga environmental, nag-employed sila og mga environmental to study, nag-study sa to respond the organism to environment. Mao na sila ang o unsa na ang organism to sa environmental to karon. So next is provide insight how organism adapt. So sunod mo ni ang mga organism unsa na pag-adapt sa nakabag-ong environment karon condition. So mao na.
Sir, I am Joseph Ebanez Simpron, BSES 2A, and today I am going to present my video reporting about environmental application of mass spectrometry, pharmaceutical analysis, drug discovery and absorption, distribution, metabolism and elimination studies, pharmacokinetic and pharmacodynamic analysis, metabolic screening, and pre-clinical development. Pharmaceutical analysis determines the purity, concentration, active compounds, rate of absorption in the body, identity, stability, rate of release, etc. of a drug. Kani kanang pharmaceutical analysis is dali kanang ma-test kung unsa ka kanon ag drug ug unsay epekto dani sa atong lawas kung makatabang ba ni or makadaot tungod daning kuan kay maapektahan ang atong metabolism ug kaning magkonta daning drugs na may uban nga tungod sa drugs nga buang na wala sakang huna-huna manang makadaot sa nato pero Mo nang og mapalabian, manang may uban makakos nga mabuan din nga. Next is food analysis. MS can determine the composition of food products including concentration of nutrients, additives, pesticides, and contaminants, ensuring food safety and quality. Kaning food analysis is makakuan ni mo ni tig ensure sa atong pagkaon kung safety ba kuno ni. Food analysis knowledge of the chemical and biochemical composition of foods is important to the health, well-being, and safety of the consumers. Manang kita og mopalit ng tag pagkaon dapat ato kunong kanon ato sang i-analyze og makatabang ba nato og sakto ro makatabang niya sa itong lawas or wa ba ni mga pesticides ng gamit nga na kung unsay epekto lang ni sa atong lawas o basig pataka-taka ang tagpalit og nana ba mga pagkaon da hintay for example kuan nito kanang data-lata na o inigkuan na mo inigkuan nimo da di nimo mabantadan man ang makadaot sa mulawas nga kana pong magkuan kag pagkaon da di nimo tarongon og luto nga na ba man ang makadaot pud na silya mo ni among topic sa kaning environmental application of mass spectrometry.
So, in conclusion, MS is an analytical technique that is widely used in environmental science to analyze and monitor various aspects of the environment. It plays a crucial role in research and monitoring due to its sensitivity, specificity, and ability to identify and quantify a wide range of chemical compounds. So that's all. Thank you.